one. Let's see if we can get the stuff set up how I want it for the stream. So, I haven't really done any streaming for a while. I'm very busy with trying to get the game progressing and all of that. But today we're gonna do a little bit of streaming, we're gonna do a little bit of audio programming actually. Something that I haven't done a whole lot of on stream. But today is the day. I want to get a certain feature into my game audio system and or engine, whatever you want to call it. So as you may know, if you followed me before, I use mostly my own tools to build the game, and stubborn as I am, I have my own audio tool as well, which looks a little something like this. Let's actually go ahead and cut the background music for this stream, at least for right now, because I'm going to be working with audio anyway. Right, so Timbre looks something like this. You have sort of a flow graph where you can put things, and it sort of defines an event in the audio system, and these events can then be triggered from the game code. So you have, like, for example, focus moved, button clicked. You can play these things here. I hope they come through in the mix there on your side as well. Let's maybe bring that down just a little bit. Yeah, as always, let me know if the audio levels are messed up somehow. But yeah, you have these sounds here. Here you have a slightly more complex one. So we have select a random sound out of these two. It's just randomly selecting from these wave assets that I have in the sound event, and so on. And some of these events are more complex, and they have these things that I call parameters. So here is the engine sound for one of the cars, for example. Everything is a little bit low. Let's see if we can just bring that up for myself at least. Just bring it up here from my audio interface. Yeah, you have these parameters that you can adjust the RPM of the car, and it affects the sound. Nothing super complicated, but still very powerful, as I'm sure you can imagine. Bring that down a little bit. Yeah, let me know if you can't actually hear these sounds on the stream. Like I said, I haven't done a whole lot of audio of streams focusing on audio, so I haven't really had to necessarily properly adjust these things before. So actually, the thing that I wanna improve today is related to these parameters. You can essentially just have a parameter value bouncing up and down like crazy currently. There's nothing, at least on the actual Timbre runtime side, to prevent that from happening. So you can do crazy things like this. Car, hello from Sig Discord. Well, hello back to you. Sounds great. That's nice. Glad to hear it. But yeah, if that changes, let me know. Right, so you can do crazy things like this, where you sort of have this value ping pong back and forth between like 0 RPM and 5000 RPM, and that's not very that is not very realistic, of course. Some of these sounds really don't kind of play nice with that kind of behavior, and you'd like to have a little bit of sort of filtering applied to that stuff. And so here we have Fmod, and some of these things are actually modeled a little bit on Fmod. I'm sure you heard of Fmod if you know anything about game audio. Fmod is one of the most popular middlewares for doing game audio. You can see this this parameter visualization here looks kind of similar to what I have as well, because I kind of really like the way that Fmod does parameters. So here we have the same. Oh, that thing actually probably. Yeah. Probably actually doesn't even play for you guys. Let's open that up again and see what we got. So, yes. Where do we have vehicles and engine? Right, so that now you should hopefully be able to hear the sound here in Fmod as well. So we have the same sound here. I'm using the exact same sound files. You can actually kind of more easily see them here in Timbre, these wave assets. These are just like the engine sounds at different RPMs basically. And here we have the same thing. We have just like RPM 1, 2, 3, 4 here as well. And we have the same RPM parameter. And you can sort of rev the engine here. And it should hopefully sound the same as here. At least more or less. Actually tweaking these engine sounds is kind of tricky. It's not super simple to do. And I feel like the Fmod sounds a little bit nicer than what I have going here in Timbre. But on the other hand, I kind of like working with these flow graphs more than I like the Fmod timeline workflow. So yeah, it's they both have their sides. Anyway, the thing here is that this RPM parameter in Fmod has something called seek speed, which we can see here. We have ascending and descending. So the ascending seek speed is set to 3000 per second and descending to 1200 per second. So that means that if I do like a very, very quick increase of the RPM, like that, you can see that it sort of seeks up and down. So if I just go like super quickly, like up and then down, the RPM sort of rises and then it comes back down, and it actually comes back down slower, and that is of course because we have this descending value here set to lower than the ascending one. And you can also see the actual sort of current value here by this yellow dot here in the visualization. So if I just wiggle it back and forth, you can see the dot there sort of using it as a target, but it doesn't jump immediately to the higher or the lower value. So that is at least like the first thing I want to, or shall we say the next thing I want to get working here in Timbre as well, because here we can quite simply just do like, and this is obviously not realistic. So we have a lot of different things that we need to actually implement here for this to work. We have basically the parameter here on the right. We only have one parameter for this event. You can have more of them. It's of type float. It has an initial value of 1000 and then a minimum and a maximum. I was thinking we would just like put in columns for the seek speed there as well. This is obviously on the editor side. We then need to implement them in the runtime code. The runtime code is probably actually the easiest part, because we just have a value. Currently we just have a value that we set. Instead of just setting it, we have a value that we use as the target value. And then from the current value, we sort of slowly move towards the target value up or down according to the speeds. And then we need to actually have the runtime send it back to us here so that we can show it here in this button here, which is actually probably one of the trickier parts. But we'll see how that turns out. I don't know anything about game audio, but that's neat. I also thought you just have these in code, have to tune these in code. Yeah, well, you can do that. There's nothing preventing you from doing that, and that is probably how a lot of simpler games do it. Well, these days, because Fmod and other tools like Wise, they're so affordable, you can essentially use Fmod for free. So this tool right here, you can use this one for free, as long as you make under some quite significant amount of money, probably like $200,000 or something. I don't remember the exact amount. But for smaller indie games, you can use this for free, and I did use this in a previous incarnation of this project, I should say. But I'm trying to make this game very moddable, mod friendly, and so that is one of the reasons I want to have my own system, which I can then just sort of distribute along with the other modding tools of the game. But yes, nowadays people tend to use this or Wise. They're the two really big ones. And of course Unreal has their own meta sound system and all of that. So there are a few options. They all sort of tend to like they all tend to package these sounds into so-called events that you can then just trigger from code. So here we have, for example, the engine code. We can do the copy path. Copy path gives us a path that looks like this. Sound effects vehicle grub engine, and then this guy you can quite simply start from the game code, which looks something like this. So you get an event description using that path that we looked at previously, and then out of the event description you can set an instance, and then on the instance you can do things like setting the parameter value, and this is just triggered from the code, and then it behaves kind of nicely how you would expect. So that's how it typically works, and it works very similarly in Fmod as well. Right, and this is Zig code. This is the gameplay code. So the code that actually sort of uses all of these audio things. But the actual audio library, the engine, isn't written in Zig. It's written in C++, and this editor that we're looking at here is written in C#. So we're gonna have to do quite a bit of C++ and C# today. Right, so where do we actually want to start? So we have a couple of different parameter types. We have a float parameter, we have an integer parameter. And these can just be added. You can see here that we now got this this second parameter here, which we don't actually use anywhere. If you want to use this parameter, you would do like int parameter param1, and now we can like hook this up to something. That's an integer. But I don't think we actually want to support any sort of seek speeds for integers. I don't exactly even really know how that would work. Like integers are typically used for sort of really discrete things, such as like, hey, play this sound or play that sound, right? It's not like play this and a half. So I don't think seek speeds really make sense for integer parameters, but they do make sense for float parameters. So I think at least for now we'll just be implementing them only for the float params. But yeah, maybe we'll start with this editor side. I think this is going to be the nastier thing to actually get working, if I'm being completely honest here. Nastier partly because a lot of the runtime code is really sort of nice and neat and somewhat optimized and easy to modify and iterate on, while a lot of the editor code is kind of messy. But anyway, let's start with that. Let's see what we have here on the editor side. So first of all, yes, we have event parameter data. Event parameter data, this is the stuff that actually gets packaged into... I can maybe show that as well. Let's go back to Timbre here quickly. Once you're sort of done with your program or your project, you want to export it to the game, you click F7 or select build project here. And good morning, Marcus. It's not really morning here, but good morning to you. It's more like early afternoon here in Finland. Anyway, when we're done with what we have here, and we want to export it into the game, we build the program as it's or the project as it's called, and we can see here that the event that we were just looking at is right here as well. And then we create a Timbre file, which is like the runtime format of the project. That is where those parameter seek speeds will go. And then we also build a bank, a sound bank. You can see it's actually much larger than the actual Timbre file. And this is where all of the wave assets and everything go. So we'll want to store the well, first of all, whether or not we have a speed, and then the ascending and descending speeds. Actually, we can probably just use 0 for the speed if we don't have any speed at all, if it's supposed to be sort of instantaneous. And fmod actually uses like value per second. I think that might be a good thing for us to do as well. So this thing is set up to be, let's see, edit parameter. So there's a range from 0 to 6,000 here, initial value 1,000. So it doesn't really have a unit, right? It's just a value, and then these are just like how much it can actually change per second. Yeah, I think that makes sense. That doesn't mean that we bump this up by 3,000 in one go. It's changing in smaller increments, probably like 60 updates, 3,000 divided by 60, and so on. So let's at least have that as a first sort of initial plan, and then also related to the exporting. When we actually press play here, it does like a mini export. It runs through like literally the same code as it does when you're packaging the whole project, but it is only including this event that you have selected, and all of the assets that event refers to. So when we are actually playing back this thing here, it uses the exact runtime library written in C++, even though this is C#. So there's a little bit of marshalling and interop going on there, which means that we can use the exact same data structs to actually send that data to the game as we do when we sort of conceptually send it to this editor here. So it's a ratio of another value, really. I kind of don't think it's a ratio, right? Because it's like you have an initial value of 1,000 here. I think you can actually just double click this, and it sets it to 1,000. And that means that if you if you clicked, or actually I think, can we maybe set this? If you like edit parameter now. Like in Timbre, you can like right click and then you can set it to 5, for example. I'm not sure if you can do that here, but if we what I'm trying to do here is basically just set this to like 3,000 exactly. Anyway, if we clicked here, I think this should put it to 3,000. It should basically take it 1 second to reach there, right? If we put it all the way up to 6,000, that would mean that it would take it 2 seconds. This scaling is a little wonky, maybe. Can I scale this somehow? Hello? Yes, I can. Right, that doesn't allow me to actually... Yeah, the 6,000 max value is a little silly because I can't actually really go there. Oh well, okay, that's 6,000, yeah. But it should take 2 seconds for it to go from 1,000 to 6,000, and then significantly longer to go back down. So I don't really think it's a ratio. I was thinking I would specify it as a ratio. You know, that the speed would be something like a normalized value between 0 and 1, and then if you put it to like 0.5, it would sort of jump half the way there or something. But I don't think that's really what you want. I think you want it to just linearly lerp between the two, essentially. I don't know. We'll see. We'll see what happens. Anyway, I think the first thing that we will want to do is create a new event for actually developing this this feature. I have a test project here that we can use for that. So let's not use the project that I actually use for the game itself. A little bit of tea, and let's have a new. I'm going to create a new event here that we'll call something like seek speed test. And let's drag one of these files. What should we do? We have the RPMs here. I think the RPMs are actually probably quite good to actually test this out with. So I'm gonna drag like the RPM2 there, and we'll quite simply play audio. So when we start, we play audio like this, so we can hear the very sort of even and linear RPM loop there. Now if we put in a float parameter, let's call this speed, and this would be like playback speed. So if we take a float parameter, we just plug it into the playback speed. Initial value would be like 1. Minimum would be like maybe 0.1, and maximum could be 2, right? So now if we play this, we can adjust it like this. So this is sort of a mini version of what we had there in the other project. This thing doesn't sound very good when you're like doing it at the extremes. Maybe this could be used as sort of like an idling engine sound, but it doesn't really sound very good. That doesn't sound very good either. That's why we have like several of them in that other in-game event. But this is sort of the idea. And now when we have this, we should be able to put in the seeking speeds for this parameter, and that should allow us to like just jack this up and down and have the sound sort of flow nicely. Something like that. But yeah, let's shut this down, and let's try to get all of the data here into these parameters that we actually need in the editor first. This is the event parameter data. This is actually you can see the Timbre runtime. So this is the runtime data that gets put into the game. I mean, yes, we could put it here already, but before we do that, let's try to just get it so that we can actually sort of adjust those things in the editor before we go here, because this event parameter data won't be actually populated until we export the project or click that play button there. So event parameter without the data at the end, this is the one that is actually used by the project itself. So yeah, this uses kind of annoyingly like boxed objects. This is my half-assed way of supporting both like integers and floats in one value. But like I mentioned, I don't think we will want to have seeking speeds for anything but floats. So I'm just going to put this as float. Or should I actually? Maybe it should be. Maybe just for consistency, it should be an object as well. Let's do that. And that would be like seek speed inc for or is it ascending, descending? What does the fmod actually use for? Yeah, it's ascending and descending. So not that it needs to be the same as fmod, but fmod is kind of nice. So let's use the same vocabulary here. So ascending and descending. And that's nice. We need to actually probably copy all of this over. There's a little bit of sort of perhaps unnecessary manual serialization, deserialization, and cloning and things going on here. some of this code is really quite old. I'm just sort of continuing the way that I've done it previously, but I'm sure some of these things could be done in a nicer way. So here we're literally like including these in the data that will get read and written when you save and load this project itself. Like so. That looks good. Get deserialized value. Right. Yeah, this is the part that then treats it as a float or an int. That's cool. Okay. So that's good. Maybe we can do a quick search for a .min value here to actually see where these things are actually being used. So we have quite a lot of places that use these things. Actually, add event parameter command. Right. And I'm thinking like probably these like seek value ascending and descending, these guys should be just set to 0. By default. 0 basically means like there is no seek speed, it's instantaneous. Right. Yeah, this is the event params form. This is where we'll need to mess around a little bit with actually having these things be it's supposed to be max actually. Be sort of populated there in this what do you call that? Some sort of value grid. Yeah, this is the thing that I talked about previously, where like some of these things just they just aren't very nice. But hey, this is old WinForms code, so it's not using any of the fanciest new fancy value binding frameworks or anything like that. Although you can do it in a fancier way than this for sure. Right. Right, so then we have the parameter buttons. So the parameter button is a user control. It's those buttons that actually allow us to adjust that parameter value. So this is the thing that we will have to somehow read or show. We will have to somehow show the current value. The current value here is, because we don't have any seeking yet, the current value is the one and only value that one of those parameters can have. This should probably be renamed to like target value. So target value is what you actually set it, and then the parameter itself sort of determines how quickly do I actually reach that target value, and then it shows it in the button there. Yes, so here we're filling the rectangle. That's actually drawing that red portion of the thing. And yeah, that looks good. Set value, yeah. So this should be target value. I'm just gonna comment that out because we will actually put it back in later, but it will be a completely different thing than the current value. So target value, set value, yeah. This is exactly what we want to. So set parameter. This now goes to the event preview player. So this goes into the C++ side through some shenanigans there. Adjust value. Yeah, this also is the target value that we want to have. Get value text. I'm thinking this is probably going to be, in the end, it's going to be the current value, not the target value. But let's call this, to make it very clear, that this is the target value. Target value, and target value, and target value. Like that. And that's the target value. Right, current value is what we actually then probably will want to get out, right? Let's rename that target value as well. That probably will make it so that it doesn't build for a second. Target value text is what we wanted. Now let's see if we build this. Probably won't build. It won't. Yeah, I can actually unload this one because it's not used. How do I unload project? Right there. And yeah. So event preview player. What is this? What is this thing? Build an init event data. Okay. Right. So this is actually, we want the target value here. Target value. This is the thing that gets called when we actually click play in the editor. There you can see we have a builder, a Timbre builder, build single event. So we give it the project, the asset manager, the actual event that we want to build, and it gives us a result, and that result is of type project build result. Yeah, and then we actually put that that project data along with its sound banks and all of that into a binary stream, and then we send the whole binary stream to the backend. So it's like here's this one event that we want to play, along with all of its wave data and all of that. And of course, at that point, we want to quite simply set the target value for all the parameters. Here's a comment actually. To make sure the parameters have value set in the parameter buttons before we start the event, we need to send a bunch of messages along with the data to set the parameters before starting the event instance. Because you might have the initial value of the parameter might be 1000 like we had, but you might have like 1500 there in the button. And if you press play, you expect that 1500 to be the value that you actually then see in the backend immediately. So that is what we want to have. And actually, all the time, the value that we set on a parameter is going to be the target value. We never set like the current value. The current value is then something that we can get back from the parameter and perhaps show here in the editor. But yeah, the current value is something that the runtime determines. Hey, how far have we actually moved toward the target value and so on. Okay, event parameter. Yeah, so 6 speed, ascending, descending. Have all of that. And all of those. That looks good. So now if we open and quite simply save the project, we should get like a diff where all of the event parameters have received like a seek speed ascending and descending. I bet. Let's see what happens. Now if I just save the project file, and then I go here to where is it? It's actually here in Basis Tools. Blah 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 blah. All right, yeah. It's over here somewhere, isn't it? Yeah, here we go. So yeah, you can see the project data is just JSON data. This is the whole project along with all of its node graphs and everything. And whenever we encounter a parameter, they just get, oh, they get null. That's probably not right. Is it? I don't think that's right. Shouldn't be getting null. They should be getting zeros. Why do they get null? They probably get null because, oh, that's not the one. It's this one. Because nothing is setting these guys to anything yet. Right, so yeah, and they're objects, so they don't even necessarily need to be numbers, they can be anything. Okay. Okay. Yeah, so where we actually create a new parameter, I think we actually went in and added like setters for those guys. But they are, yeah, so it's this add event parameter command. So here we actually go in and make those actually be numbers. So that's good. All the new ones now have that. But we probably actually want to do a little bit of patching up here. Right, this would be, and this is just to get the ball rolling here. This is not how I'm going to actually do it in the end, but yeah, let's just do it like this for now. And that would be just 0, right? Oh, we don't have a type, do we? Do we not? It's called event parameter type. And, oh. Let's maybe do like a fix up here. So far I've managed to do without any kind of sort of version number updates, upgrades, anything like that in these project files. Sooner or later I'm gonna probably have to come up with a proper scheme for doing that. I do already do sort of version numbering of these things, but let's do like a version fix ups, something like that, just as a temporary hack. So if you know, this would be actually seek speed ascending. Am I somehow outside of the class now? Nope, I'm not. An object reference is required. What? I haven't done C languages in such a long time that I don't remember what's what anymore. No, non-static field. Yeah, I know. This would be like this, right? I doing wrong here? Let's put it here. I was somehow outside of the class, was I? No? Okay. I don't know. But yeah, now we don't need these guys anymore. That should be fine. And we don't need this. Yeah. Exactly. So ascending and descending. You just set it to some sensible values. And of course we only need that for basically. Alright, that was in the converter. Okay, that's why. That's why. It was in the converter. Yeah. Of course, it might make sense to have it inside of the converter. We just have give it like the event parameter like this, and this would be evt dot. Yeah, I think this is how I like to do it because it's sort of part of the deserialization of this data. So before we return the event parameter, we do version fix up on it, like so, and that should be it. So now if we open this, yeah, okay, now we can now we can't actually load the thing. That was unfortunate. So you know what? What we could do here is this thing instead, which probably will let us get away without having that version fix-ups there. So I'm thinking that it probably doesn't know how to read that now because it's encountering a boolean, or it's encountering a null, error converting value null to type system single. Yes. Yes, so it's basically like this thing. Okay, well I don't want to get hung up on this, so let's just undo this thing that we did previously, and we'll do it again. So I'm gonna shut that down. And now we'll try again. So now it should load. And if I save this, yeah, now we can see now we have those zeros there instead. And we had one which was just a 0. That's, yeah, this is like testing data, so these don't necessarily make any sense, but it's called some int. It's type of integer, and we can see that they do get integers instead of floats. That's nice. Okay. Okay, so that's good. Now, of course, we lost that one event that I created, so let's just quickly recreate that. Now that we have sensible project data. What did we call it? Seek speed test, I think. And a play audio. I used, I think, RPM3. Event was start, and then we had a parameter. We need to put in the parameter speed. I think it was called initial 0.5. Actually, let's make it larger. Let's make it we give it the 5,000 there, which is like kind of sensible for something like an RPM. And then we need to actually get the parameters. So float parameter, plug it into playback speed, audio source, and play, and that should be it. What? Oh, yeah. Yeah, let's maybe not play it back at like 1000 times the speed. That's stupid. Though I do like this this range that we have now in this float parameter, but obviously we can't plug that in there. I'm just being quite simply stupid here. So let's scale it down somehow. So we need a float operation. Just drag one of those in here, and we can multiply this by something. Let's plug that in there and hook that into the playback speed. So let's make it so that 1000 equals the playback speed of 1. 5000 equals the playback speed of 5, right? So actually we want to divide instead, and we just put 1000 there. Save that. And that makes more sense. Yeah, it's a little crazy with that that max value there, but it doesn't matter. Minimum can be like 100 maybe, so we don't go quite to 0. Like that. And now this button doesn't allow us to go below 100. And it sounded kind of obnoxious, but it's supposed to be just like very, very sort of obvious what that speed value is now there. So that's nice. Okay, so now we have an even better test event for this new feature here. Okay, and now we can save those values, those seek speeds. Now we need to be able to adjust them, and I think we now need to do this somewhat nasty thing where we go into the event. Let's see what that's a completely wrong project. Close all of those down. Event parameters form. Right. Welcome to WinForms in the year 2024. Nothing works. My hack is to have a specific designer configuration here, and then probably need to do a rebuild. It has to do with Visual Studio. With the Visual Studio Win32 WinForms designer not really supporting x64 binaries or something like that. But now we can see the event parameters here. So basically what we want to have is a couple new columns. And I do wonder, did I actually make those columns in the designer? Or did I do it from code? And I'm not sure. Let's have a look, see. Load parameters. Yep. Here's the editing part. Yep. Yeah, they don't seem to be here, so they're probably done through this designer somehow. Let's see if I can find it. Columns. Yeah, so this thing. I do like WinForms for a lot of reasons, but I don't like this designer. The whole sort of designer development experience seems very archaic. But basically, we want a new column, and let's call it. This component is called better list view. That's why they're all called like m_better list view column header something. And this would be seek speed ascending. And then we have the same thing with the descending. And then we need some sensible text, something that's actually very short. Here we just use max. So let's do seek ASC and seek DESC, something like that. Right, have we changed anything else? We've changed actually like the width. Okay. Yeah, you can see type is narrower, and I think these probably also need to get narrower, so that we have space for all of these guys. They're basically just numeric values, so they don't take up that much space. The name is the only one that might actually do that. Something like that. Let's see what this actually looks like in the editor. Oh, but I can't actually run this designer configuration. I need to go back to release or debug because of reasons. Right, so we can see that we can't actually really see those, and I think that's because I had some very clever code for adjusting those sizes, those widths. Try to find that. Yeah, it's probably actually here in this event parameters list view. Yeah, here we go. Here we go. So this is the width that we can actually see. So this should be equal to almost 1. That would be 60, 70, 85. It's actually, the sum is exactly 1. Okay. So we do need two more of those columns though. So if we have, we have 60, do a little bit of higher order math here. If we have 60 and 60% divided by 3, we get 20. If we have 60 and we divide it by 5, we get 12. 12 might be a little tight, I'm thinking. So I wonder if we can, well, we can try. We can try to do that. So let's do, we now have two more of those columns, 5 and 6. We're gonna do what? 1, 2, 3, 4, 5. Yeah. Okay. Yeah, we're gonna make all those to be 12. That's gonna be kind of tight. Yeah, that's a little tight. I can see those seek ASC and DSC being a little too long, maybe. Might have to shorten those even more, but we'll see. Right, so if that is 25, we have 15. That doesn't need to be 15, I'm sure. That can be just 10. That gives us a little bit more sort of space to work with here. Right, did I get that right? Let's do a quick sanity check here. 13 times 5 is 65. Plus 10 plus 25. Yeah, that equals 100. Right, so I think this probably works quite all right. Let's just make that ASC and DESC so we get those speeds so that they don't get cut off there. Maybe we can take a few % of that one, and we give it to the type there instead. Yeah, this is also interesting. Like now, I can suddenly, at least for a little while, I can use this in release mode. This designer, but that doesn't always work. Sometimes it just fails to show me anything here if I don't go and build it via the designer configuration at least like once. All right, that looks good enough. Cool. Okay, so we can edit these guys. We can edit all of these things. And if we edit one of them, make that speed 2, you can see that we ran like a command that renames the event parameter. Now we can undo and redo this. So there's also one thing that I want to have working for these values, that you can do undo and redo, just like everything else in the editor. And because of that, it's just there's a little bit more work involved in actually changing these values. This is probably the most boring part of this whole project. We'll get to mess around with audio very soon. Let's just have a quick look here in this event parameter list view. Is there anything else here that involves specific columns? Doesn't look like there is. This is mostly to do with like drawing and things like that. So that's fine. So the rest of this actually takes place here in this form itself. Let's have a stroll through this guy. And see what it has eaten. Get name sub item. Parameter name. Oh, name, right. Okay, get value sub item. I think that's probably what we want. Yeah, so these are used by the actual commands. Value name. Yeah, all of this should work, I think, just out of the box with all of them, except we do need to actually implement these. I'll have like an else if clause here for this. So ASC, that would be 5. And then the descending one is 6. And here we have the same thing. Six-speed ASC. Like so. And I think we actually might want to leave these out if the type is not a float, but for now let's just put them in all of the parameters. Like that. Is there anything else? Probably is. Yep. Here we go. After label edit. All right. You can see there's a lot of like just manual copying around and general nastiness to this code here. Not super proud of it. Well, that's how it usually goes with tools in game development. They quite often just get kind of nasty and copy pasted after a while. At least that's my experience with these things. Right, so what we're doing here, we're getting basically like the label that we just put in, and we set the parameter value using a command, new value, string to value object that casts it again to a single or int 32. Yes. That's all right. Hey Matt. Nice to have you back. Right. So hopefully that's all of the nastiness that we need to do now to be able to actually modify these guys. So basically what we should be able to do is add a seek speed to one of the parameters. We should be able to undo and redo that thing. Set the value, undo and redo, setting the value, save the project, open the project back up and have those seek speeds be there persistently. In a persistent manner. Let's hope that is the case. I haven't forgotten anything. Right, ASC, DSC, that doesn't look right. So we have something here that probably reading it from the max. Let's see. Yeah, here we go. So that would be seek speed ASC. That would be seek speed DESC. And there we go. There we go. So 0 and 0. So now if we set this to like, so this would be now in the change in value per second, right? So we can make that 100. Or if we take the same as we have here in Fmod, that would be 3000 per second and 1200 per second. So let's do that. Let's put those in. So 3000 and 1200. And yeah, I need to somehow make this UI more obvious to what is actually happening there. But for now, let's just see if we can undo those. That's nice, and we can redo. We get back the values. Now, if I exit and save this thing and load it back up, we should have those values there. Like so. Isn't that nice? We should also, because this is a float one, we should be able to do like 3000.1. But we should not be able to do 3000.w. Then it doesn't convert it to the proper thing. And it doesn't accept it. Okay, that's good. So now we have the actual speeds there. Now what we can do is export them to the runtime. And I think actually with not that much work, we should have the runtime use it properly. And then the rest of the work will actually be sort of visualizing the current value here in this button. So we should be able to basically like crank up the speed like a lot, and we will not see any difference here in this button, but we should be able to hear the difference because the seek speed is being applied there in the actual on the audio side. So let's make that happen. That should be relatively easy now that we have the nasty UI stuff done. So first of all, we need to go into the runtime data here and set this would then be a public float seek speed ASC get set. Do we want to do like a float one? Yeah, I think we'll just keep it as seek speed ASC and seek speed DESC, and we quite simply don't serialize those if it's an integer. I think that's probably what we want. Did I break your ears? Yeah. I'm sorry about that. Let me know if like the audio levels are just completely obnoxious or just blow out your ears. We're working with a test event for getting seek speeds from these parameters set up. and we need like a sound that is very sort of obvious. Actually, what we might want to do, let's do one thing. Do one thing. Let's maybe change out that sound to something else. Then here's a piece of music. Let's see if that piece of music is less. If it's nicer on your ears. So we have this kind of nice intro to this song where we should be able to like see the. I think this will probably work quite just as well as this RPM here. Yeah, so this is the thing that I spoke about earlier. If you have, even if this has the initial value of initial value of 1000, if you set this down to something like 500 and press play, you expect this 500 value to be the active value there, like this. And then you can play around with this. Yep. At least they're not doing anything with delays and feedback. They can get out of hand really easily. Yeah, they can. That is true. Yeah, I mean we can feed in one of these parameters to like a filter if we wanted to. We could do like what should we do? Like a low pass might be kind of interesting. So you can expose more things here and do like put this as a low pass filter into one of the filter slots on that thing. And we can create another one which we can call like maybe like frequency, and let's make the maximum something like, I don't know, 500, maybe 2000. Initial is like, I don't know, 500. And then we start messing around with this, and this can bring some really interesting sort of sound effects to this. So now we're like letting only the low frequencies pass, or you can do a high pass. Things like that. It's all fun. But yeah, let's not do that for now. Let's instead concentrate on this one parameter to make sure we have the seek speed working properly. So we should be able to crank this up to like 5000 now. Like that, and you should hear the speed going up linearly, kind of like as if I did this. According to this ascending value here, and then descending is the other way. Are you like an official DJ now? I am the official DJ of this stream. Yes, I'm the official DJ of this development stream. And that is the extent of my DJ-ness. Okay, let's see if we can make that happen. So, serializing stream.put seek speed ASC, stream.put seek speed DESC. And we just don't put them there in the integer case. They will remain 0 in the integer case. And then I guess I better do seek speed ASC and DESC here as well, even though I don't think I really do deserialize these on the C# side, but I like to keep these symmetrical. Right. Yeah, you have to run them through temp variables and then assign them. Because properties, as far as I know, can't be used as out parameters like this. Right. And I think that's that. Then let's see, convert parameters. Right, then we have to actually put this stuff into here. So this convert is like convert into the runtime format. And again, we have a little bit of handwritten sort of value transfer here that we might be able to automate somehow, but especially when it comes to the export phase, I like to do all of this by hand, because we'll have C++ reading this stuff on the runtime side, and we can't sort of assume that anything that C# can like auto-generate for us will be able to match that sort of bit by bit. Next video, I'm making a DAW so I can make a game engine so I can make a game. Yeah, pretty much. Pretty much. Okay. I mean, isn't that what everyone does? Can you even make a game if you don't make a DAW first? Is that a thing? Is that a possibility? So now I think we have everything here in C# ready to work, except for the visualizing of the actual value here, which is actually probably going to be somewhat tricky to do. But well, let's get back to that later. So now actually if I play this might crash. Yeah, exactly, because now we're writing data that we are not reading. You can see Sound Manager load project crashes because the data format has changed. And so what we actually probably want to do is bump the version number of it. So if we go to Basis, Tools, and Project Data, just bump that version to 5. So if we actually try to load that, the runtime goes like, oh, I'm expecting version 4, what are you doing? Now if we play this, it should probably assert. Yeah, like you can see, incorrect Timbre data format. Loaded version is 5, expected version 4. Okay. So let's make it expect version 5 now. That should be relatively easy. We take the event parameter data. I'm just move it off to the side here so that I can see it. So Timbre event parameter data CPP. Here's a to-do comment for myself that I should put this in some kind of union or something, but the data is so small that I haven't bothered. It's quite simply ridiculously small. Seek speed ASC. Seek speed DESC. And stream put seek speed ASC stream put 6-speed DSC. And instead of put, we do get here. And these are just regular variables, so we can just get them straight out of it. And I'm actually going to just set, I'm actually going to just set this to 0. Actually, I'm not going to do anything. That's fine. It's fine. Yeah, I think that's probably everything we need to do. And then we need to bump the version number here as well. So Timbre, probably, what is it? Project data. Serialized version 5. Right. And now if we go here and we rebuild the editor, it actually links to the C++ code to do the previewing, so now we should be able to preview this thing again. Like we can. That's nice, but it doesn't do anything with those values yet, so let's make that happen. And now we are in the runtime side, so we have the parameter data here. There's no sort of parameter class or anything like that on the runtime side. Instead, what we have is a small struct here in the instance. And I think this is now where basically like the whole rest of the logic will live. Oh, 1 second, I have to take a phone call here quickly. All right. Sorry about that. Anyway, this small struct here, event parameter value, is essentially the whole runtime. This is it. This is where those things live in the runtime. You can see that the instance, the event instance, has a vector of these guys. Let's search by that name. Yeah, we have some Merlin things. That's the particle system, so that's not what we're interested in, but we have it here. So event instance init. It resizes and it gets it from the data. So this is the stuff that we actually already modified. Yes, we have the seek speeds there, so we can get those seek speeds plugged in. What else? Set parameter. So this sets the float value to the value that you are actually well, the one and only float value of the parameter currently. So this is the important part. Here we don't want to set it. We don't want to set a target value, and then we want to start tracking towards that target value. That is the important part. Int value. This can probably be exactly as it is currently. And so this basically this method here is what is actually called from the game then. So we're kind of close to the game code now. Get float parameter value. This is the thing that actually gets it out of the event and into the audio side, I think. I bet that is what it is. Let's see. So in Timbre, yeah, float parameter node. So when we hooked up that parameter there in this node graph and fed it to the playback speed, this is the code that gets run. It gets it out of the event instance and writes it to the value receiver. And that's it. That's all there is to it. So the runtime is like super simple. It's basically a vector of values. And then you can get those values out of the vector and you can set them. Okay. So, what I think we will need to do is not super tricky. We want to probably put in some spacing here, because these things will now be sort of... Some of these things will be related and some will not. So we have the float value and we have the float target value. And I think I will... Actually, before I do anything else, I want to rename that float current value. So that is the current value of the parameter, the thing that we can't set directly, but which we actually want to figure out. The only place where we can actually set it directly is here in this init, because we want to initially set it, and then this set parameter value, this won't actually set it, but this will get it out. Right, so this is not correct. That we want to change that. And we want to have a target value. I want to do that. So let's set the target value to the same thing. Float target value is also initial float. And what we set here is the target value, like so. Then we have float, seek, speed, ASC, float, seek, speed, DESC. This float here is perhaps unnecessary, but I name them in the same manner to make things super obvious as to what is going on. And yeah, we just set everything on all the parameters regardless of their type. So the int value is also set here regardless of whether this is an int or not. That may be completely fine, but those seek value, float seek value ASC here, this is going to contain garbage if it's not actually a float. So that's a bit annoying, but it's probably not a big deal. We can set them to we can zero these out if we want to, basically. And that is what I was actually sort of thinking of doing previously. So here we would do, like, if this is a float, we get the values out of the stream, and then for the initial int, we just set that to 0. We set min int to 0. Oh, we set max int there. Let's keep the order the same. So min int 0, max int 0, initial int 0, and here we should set all of these guys to 0. All of these float guys. Right, so we deserialize the thing that we actually want, and then we set all the other ones to 0. That just means that then at runtime we don't have any garbage values in memory, which is probably good. It's on all types, even well, it's on all types regardless of parameter type. That should probably be called value, because the layout of this struct has changed a little bit. So these are like related to float parameters, related to int parameters. Maybe I'll have some other stuff there for the ints in the future. So let's make sure this builds. This should now build, but it will not behave correctly because we are setting the target value, float target value, but we're reading the float current value. So with the current code, what will happen is that it will always have the initial value returned by this thing, or used by it. And that's fine. What I was thinking was that we would add a new method here called something like seek parameters. And if in the update here, if we are playing, perhaps right before we update the node graph, or after, not sure, probably actually before, right before we update the node graph, we do the seeking of those things. So let's do that. Let's add a new method. I'm gonna call it like update parameter seeking. I think that's probably the most obvious name we can give it. Let's take that one and put it. I'm gonna run it before the node graph update. Like so. And right. Drag that off to the side. So we'll do, let's see what we'll actually do. Do event parameter value p in parameter values. It's not necessarily the best name for that anymore because it contains other things besides values, right? Yeah. Anyway, it's probably fine for now. So if this thing is, if p.typeID is float, then we want to do some further processing, right? And I think we want to check first of all if we are at the target. So we will need to have some small epsilon here that actually checks if we are close enough to the target. We won't like oscillate above and below it all the time. We just keep it at the target, right? So we can do basis math. Actually, we can probably just do math equals, so p dot current value. If it equals to p dot target value, then we are at the target. That's fine. Though I wonder, before we actually do this check, we should probably check if we have a speed. Right, so if p float seek speed, how do we actually want to check this? So it can have one of these can be instantaneous and the other one actually like a valid speed. If both of them are 0, then we don't want to do anything. Yeah, okay, actually, this setting here, blah, blah, blah. Let's quite simply put a boolean here, which stores whether or not this has any seeking enabled at all. So we can do the check when we initialize the value, and then we can just like use that boolean. That is nicer in some sense. So seeking enabled like this, and we'll do this immediately up here. So if parameter values I seeking enabled is if not math equals seek speed ASC 0 or the descending one. And the reason we use the math equals there instead of just using equal signs is that we want to be able to use like a small epsilon there as well, because of how floating point works. Actually, 0 can typically be represented quite exactly, or exactly in standard floating point. But still, we can do it like this, no problem. So seeking is enabled if the speed ascending is not null, or 0 rather, or if the seek speed descending is not 0, then seeking is enabled. And that allows us to do things like this, where like if not seeking, if not p dot seeking enabled, we quite simply continue. We don't care about this thing at all. And that would actually mean that we don't have to check this float here, but it's fine. Maybe we can just put this into that check and leave that out. Okay, so now we know that we are seeking either upward or downwards. So if we are at target, so if float current value is target value, what we can do is set it to be exactly that. So again, if we have this this sort of this epsilon here, this small sort of window where it kind of snaps to the target value, then we want to set it to be exactly the target value. So float current value would be p dot target value, and then we can not break but continue. Skip the rest of this. And now, if we continue, we know that we are seeking and we are not close enough to the target value to actually snap it. So if the p target value is larger than p current value, like so, ascending, right? We actually need the delta time here passed into this guy. I just realized, but luckily we can get it here. Delta time, like so. So we are ascending, okay? So now we need to calculate how much to actually increase the value this update. So target value is larger than float current value. So let's do like a change is p dot float seek speed ascending times delta time. Right. That should be basically all that we need. And that would make the float current value would be get min of current value plus change and current value. So we basically we clamp it. We clamp it to the target value. No, sorry, not that. Yeah. So current value is current value plus change or target value. Yeah, the minimum of those two. Else we are descending. And this would be, of course, then this, and let's put a minus there Actually, we can just, the change can be positive, and then we just like take it away from there, and we need to use get max instead. Right, I think that makes sense. Does it not? I think that makes sense. So if we don't have any seeking enabled, this will fail, and it will skip this whole thing. If we are seeking, but we are close enough to the target, we just force it to be the target value, and then we continue. There's an extra semicolon. If we are not at target, that means we are seeking, and we can be seeking up or down. So if the target value is higher, then we add to it. And if it's lower, then we subtract from it. Yeah. I think that should work. So we're setting the target value. If we are not seeking, and this is again one of those places where that boolean is handy. If we are not seeking, then we need to just set the current value directly, right? Current value. Otherwise, it will never get set because it's being skipped by the actual seeking logic. Yeah. I think that will work. I'm gonna go get a little bit of water. When I'm back, we're gonna test it out. All right, let's have a look here. So that built, and let us go into the editor. Like so. And we have this seek speed test. If we play this, it plays nicely. I'm messing with my mouse speed here. Hey, look at that. So if I set this to 5,000 now, you can sort of hear it. You can hear it go higher and lower. That's really nice. So if we set this ascending to something kind of low, like 500, set this back to the normal one and play it. And now I just set 5,000 here. We should hear it slowly rise. Let's set it back to 100. It should rise a bit faster. But it doesn't go to 0. That's fun. Isn't that fun? Let's make sure that we can actually jump in one direction. So let's make ascending 0. So it should now jump. It should now jump immediately higher, but then go lower with the seeking. So let's make it like 3000. Oh, look at that. It doesn't work. Yeah, so there's a bug there still somewhere. So it looks like if we... Oh. Yeah. Yeah, I know what the bug is. We need to track separately if we're seeking up or down. Okay. So basically, like this is the thing. We had seeking enabled, but only in one direction. And so yeah, the problem is obvious to me at least, but it's not obvious how I actually want this to work. Do we want to do something like? Actually, yeah. Let's get rid of this thing completely. So, bye bye. I was thinking it would be nicer to have a boolean there than like just doing those 0 checks, but it's probably actually not. So if the value is larger than the current value, let's actually just do like float current value, and I need to enclose all of this in curly braces, otherwise C++ gets cranky. So if the value is what happened? Right, that is what I want. If the value is higher, no, value is higher than current value. That's what I want. And math equals p parameter values. No, MP parameter values index like so. If this is true, then we want to set the value, right? So if the value is higher than current value and we are not seeking upwards, then we set the value. Or if the value is lower than the current value and we are not seeking downwards, descending, then set the value. That's what we want. And we need to do the checks there as well. I kind of like these bools for some reason. I don't know why I don't want to really do those. So seeking ascending enabled is that, and seeking descending enabled is that, right? Something like that. And then we can do not seeking ascending enabled. Oh, that would be this whole thing. And here we can quite simply do if we are a float and then we need to check an OR on those two. So seeking ascending enabled or seeking descending enabled. And technically I guess these guys will just, they should be up there. Yeah, that should fix it. So we're always setting the target value, that's a given. We might also be setting the current value. And that depends on the direction we want to go and whether or not we should be seeking there. Yeah. That's better. Mm-hmm. Yeah, that looks good. So let's try that and make sure that we get the thing we want. All right. All right, cool. Let's make ascending 0. So now we should jump upwards and seek downwards. Yeah, that works. 3,000. We do like 3,000 and 500. Or we can do it the other way, where we have descending is instantaneous and ascending is seeking. Cool. All right. This is basically like the feature is now implemented as far as the game is concerned. This is what we need. This is what we need to have these basically get rid of these like poppings and weird like unnatural sounding effects in the game. And so it's kind of tempting to stop here, but I think it doesn't really necessarily feel all that nice to use if you can't actually see this value here. So I probably need to actually make that happen. This is interesting. Like the the initial value here is 1,000, as we can see here from this list. We have it set here to whatever it is, and it is actually seeking there every time we start this thing. I wonder if I should fix that, if I should treat this as the initial value in this case. Yeah, I don't know. I don't know. It might be fine. Right. I mean, if you really need the initial value to be something specific and you don't want to seek it there, then you can just set it here in the initial thing. So yeah, I think that's probably fine. There's like one thing that I might want to do here. Like if we have this int int parameter here, we shouldn't probably be able to even change these things. So I'm thinking probably disable that. And then if this is 0, then maybe we should actually write something else here, not have it as 0, have it as like a none in parentheses or something. Let's see if we can make that happen. Might be tricky, or it might be easy. So this is the parameters form. Before label edit, don't allow editing the parameter type. That is something that we might want to use. So if event args sub item index equals 5 or 6, then we are in those seek speeds. And now if the type is an integer, how can we do current event? How do I get the type? P current event parameters I, right? So it depends on which index we are in. Okay. Okay, so we can probably do. Let's have a look. Yeah. Yeah, so that's how you get the current parameter. Like so. If p dot type equals integer, then we don't allow editing those things. Don't allow editing integer seek speeds, or rather integer seek speeds make no sense, because that's actually what is the case in my opinion. Seek speed test. So we should still be able to change that, and we can do that, but we cannot change that. We can change the max and the min and the initial, not the type. Change the name. Can't change the ascending or the descending. Yes. Okay. Good. Another small change that I want to do. Let's see if look at this. Now it just broke. It just broke. Now I need to do designer, and then I need to right click here and do rebuild on the Timbre editor. And then if I'm lucky and I pray and offer a goat to the Microsoft gods, then the designer will work again. Let's see. Event parameters form. Yes. Goat accepted. So let's go into the blah, 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 blah. What is it called? I have the wrong control selected. Columns is what it should be called. Columns is right there. And I want to see what happens if I change this text here to ascending per second. I think that should make it clear what is going on, what the values actually mean. Right, now I can go back to release. Yeah, those seem to fit somewhat nicely there. Somewhat nicely. It's not super nice, but typically I work with this in like full screen mode or almost full screen mode, so I think it's fine. Coolio. Alrighty then. So the next thing then would be to periodically read this value and send it from the runtime to this editor here, and then show that value somewhere here in the button. So basically the same as what Fmod does here with this little yellow half sphere or whatever that's called. That's actually, now that we have this this seeking working, I'm going to quickly go into my game project here and go into engine, and we can set this to 1300. I know that was actually 3000, and this is 1200. And now let's play around with this a little bit. Doesn't sound necessarily quite as nice as the Fmod one. I think there's still a little something that I need to look at here. This is definitely nicer already. But yeah, it does feel a little weird when you don't see actually the value there in the visualization. So I think there is a point to be made about showing that. How would we do that though? How would we make that happen? So there's a project here called Timbre Bridge, and this is needed because the Timbre runtime is C++ and the editor is C#. So we need something to actually plug those two together in a sensible way. And there's a class here called Event Preview Player Backend. And this guy has a bunch of messages that can be sent back and forth between the two systems. So you can see backend to editor, print and event finished. Those are the only two events that can currently happen. And the other way around, the editor can send things to the backend. So signal and set parameter, this is the actual way that we can change those parameter values there in the preview. So we can actually rev the engine like we did there just a second ago. And I think the way that we do, like parameter name here, for example, or set parameter name, this is a very strange, if you haven't seen C++ CLI before, this is a very strange Microsoft specific way of representing .NET types in C++. So it has this I don't even know what to call this. That like some sort of, I don't know what the hell is that even called, that this character. Looks like the roof of a house, but this is called a handle. So it's a managed handle to a string, and then we have the float value, also used for integers. Integers just cast a float and then back to an int. And then we create an event preview message out of it with this weird GC new operator. Yeah, public ref class. This is like a managed reference class. It's a very strange dialect of C++, this. And then we push it to messages, which is like a systems collection generic list. So this is basically just the standard .NET list, which is how the C# side can then actually view this as just a normal list. But in this case, it's not going to the C# side, it's going to, because this is a set parameter, it goes from the editor to the backend. So there's an update here. Process messages going from the editor to the backend, like this, and we process the message set parameter. We get the C++ string out of the managed strings is the basis string, and this is now then using the set parameter function. This is the same parameter, set parameter function, as the game would then call. So with the name and the value, if that makes sense. And the way we can get the thing out of it is using get float parameter value. This is something that we modified previously. So this now returns the, what's it, the current value. Let's just make sure that is the case. I'm pretty sure it is, because it would not have been able to do those nice seekings. Yes, so it returns the current value, and that is of course the value that we want there in the buttons, in those parameter buttons. The value that we currently see there, the value that we can set, that is the target value. We want the current value as well to be shown there. So we can, at least in theory, call this guy if we know the parameter index. And we can construct some sort of message that goes the other way. So from the backend to the editor. And then we need to unpack that in the editor and update those buttons with it. And I think that is probably how we're going to make this happen. But there might be something that I'm forgetting. Not sure. The character's name is Carrot. Yeah, I had Carrot in mind as well. I was thinking it might be Carrot. But then I thought, isn't Carrot like, isn't this like this blinking thing here in the address bar? Isn't that like a carrot as well? But yeah, I actually had Carrot in mind. Yeah, okay, so it is actually a carrot. So you were quite right, and I was quite right as well. But I was so unsure that I didn't even say it. Yeah. So what is this called then? Blinking line in text field. What is that called? Oh, that's the cursor. Okay. Also carrot. Well, less common. It's also carrot. It's written in Google, so it must be true. Yeah, cursor is what I typically call it, but I've heard it be called carrot as well in some places. Oh well. Right. So where would we then? Jesus, I can't talk. Where would we then actually pull those values out of the backend? Where would we do that? What is actually calling this update? Is that, I think this is running on a background thread. I'm pretty sure it's running on a background thread. Send return message. That is how we can actually get things back into the editor. So we can probably use this to send things back to the editor. We can actually just put a breakpoint here, I guess. Let's see what is actually calling this guy. Let's use the dev project. Yeah, so it's a thread, player thread update is what is calling it. It's a very simple little thing which sleeps 10 milliseconds after each time. The actual audio playback is running on yet another thread, on the audio thread. But in the editor, when we're previewing an event, then this logic for this node graph is running in that thread, and so that's why it's sleeping 10 milliseconds, because these things take virtually like no time execute. Well, that's not true. It probably takes like 1 millisecond or something, but very little anyway. Right, before we actually do move on to that, I wonder if I should do that other thing that I mentioned, where instead of writing 0 there in the event parameters form, we would actually keep the text as something else. After label edit. Yeah. Let's make a small helper function for us here. So let's do like private void get seek speed cell text, something like that. And the seek speed is actually a float every time. Seek speed. It's not a void, it's a string. Returns a string, and I think this actually gives us. What does it give? Right here is this. Here's the text. Yes. So right. We can kind of, I guess, consider that a float, but even though it's an object. Let's keep it as an object for now, because I think that is perhaps what it actually is. Yeah, those are objects as well. Okay. However, the first thing I'm going to do here is treat it as a float, because it is currently always a float. So seek speed, float, or maybe we can do like convert to single seek speed. If seek speed equals 0, then return none. Otherwise, return seek speed to string, and maybe we could format it so that it's actually using 2 decimals or something, 2 decimal points, 1 decimal point, whatever we want. But for now, let's just do this. And this is just so that if you see 0 there, it actually makes it more clear that, okay, it has no actual speed. And the way we can do this is because like the tag is the object that actually then holds the actual value for this. So here again, we want to use our new fancy function. Sub item text, event args, or is it that one? Don't actually know. Or is it both? Label and text. It's probably actually both. Yeah. The value has been sort of set already. At least I'm thinking that is what is going on here. That's not what I want. I want to do that. Right, so that's ascending and that's descending. Cool. Let's see if that actually does what I want. So float none. Set that to 3. Oh, if I undo it, it goes back to 0. It's always something that that doesn't work as you expected it to. So this would be like set parameter, set event, parameter value, command in the Timbre editor. Yeah, this thing sets the text. All right. Let's not worry about that right now. I can set that later. I can handle that later in some more reliable and robust way, I'm sure. Just get rid of that. There we go. Okay. So then let's continue our investigation here regarding this preview of the value. So send return message is called from somewhere. So it's called from print callback and from the update when the event has finished. Okay. So this seems like a perfect place basically for us to send back those updated values. Sound Manager update is the thing that actually runs the update, which would then actually change and seek those current values. So after the update we can send those. And what that then makes happen on the editor side is that we have an event preview player which should have some way of receiving those messages. Right, so process return messages. Yes, indeed. So this guy gets a bunch of messages and then does things with it. And I think that what we actually probably should do here is collect all of those parameter values that we have and collect them into a list and then update that panel, which is called a flow panel, above the node graph in one go to avoid like redrawing it all the time, but that is an implementation detail. The interesting thing here is that we have a for each loop. We just loop over all the things that have returned from the backend. Okay, so I think we're actually using strings when we actually set those parameters currently, not parameter indices, even though the game can use parameter indices to avoid having to send strings back and forth all the time, but maybe we can use strings at least for now here in the preview. It's not super performance critical anyway, and we have everything we need to actually do that. So when we set a parameter, we have string data and float data here in this message. So this is exactly what we need to send back that thing. So basically update parameter current value from the backend to the editor. That looks good. And so in update, if we go here, it's a static function. Okay, that's fine. Probably like here to do update parameter values. Yeah, the nice thing is that we shouldn't have to actually modify the runtime at all to make this happen. We should be able to just query the thing from the runtime and get it working that way. One thing though that actually I just immediately started thinking here, do we know how many parameters we have here and how we can actually access them and get their name. We can probably actually get it from the description, right? So we create a description, and then out of the description we can create instances. So parameter index, all right, but we need to know the name. Why don't you want to show me your contents? So event data, parameter data. Right. The parameter index is quite simply the index into this very straightforward array that is part of the, here we go, basis vector event parameter data. This is the data that we modified earlier when we actually exposed those seek times to the backend. So we have all of this, but can we actually read this from this backend? We might be able to do it, but I'm not 100% sure. So this project data, this is, oh, that's just a byte string or byte array. Load project. So this guy probably creates one of those data things internally, yes, and then gets the stream into that. So this guy would have all the names and indices that we need. How can we access this guy then? I'm not sure we necessarily can. So basically what I want to do here is for all the parameters in the event that we are previewing, I want to call let's see, where do we have it? Instance. It's not there. It's easier just to look at it here in this C++ side. For all of the parameters in this event instance, I want to call getFloat parameter value with the index of the parameter, and I also want to have the name of it, of the parameter. So we can get the index of that parameter for or from the description if we have the name, but we don't have the name currently. We don't actually even need. We don't actually even know how many parameters the thing has. It just knows it internally. But I would like to know that to be able to iterate over them and send back their values to the preview. So how do we do that? Now this guy essentially knows it. Right, event data. Okay, this is how we can actually access it. Yes. Yes, because this description here, event description, this guy, it exposes its pointer to the event data. This is the data that is loaded from disk when we want to create instances of this event, which in turn creates one of these event descriptions. So this is the data, and this data then has a vector of event parameter datas. And each event parameter data, well, it knows its index because it's literally the index into this guy, and it knows its name. That is how we can get it. Okay. And I think what we will want to do then, I'm just going to drag this off to the side, probably drag the description as well. Just make it a bit easier for myself to work with this. Oh, actually we're in the wrong, yeah. I jumped to the other Visual Studio. I need to be here in the tools. So this player backend thingy here, I think this guy should have a list of all the parameters. So basically their name and, well, their names essentially, their names, and it should have it in .NET form, so that it can quickly and easily then send them back to the editor, which expects them in .NET form. So let's do something like this. Let's do static list of what is it, system string or something like that? Yeah, system string, and then we put in the character, as we now know it is called, and it is called something like parameter names, and we can set it to a null pointer. Can we not? Oh, this also needs to be a handle, is what this is called. It's not actually a pointer, it is a handle. And we will create and populate that list when we load the data. So set event preview data. This is where it is actually happening. We're loading the project. We're loading, or preloading rather, the main sound bank. And then we create the event description here. And here we can get event data, I think it was called. Yes, event data. And this is preview event description get data. Right? Why are you unhappy? It is undefined. Okay, let's make it defined. Timbre event data. It's still unhappy. It probably needs to be Timbre event data. There we go. And now for whatever was it called? It's called event parameter data. So for const Timbre event parameter data p data in event evt data parameter data. So we iterate over all the parameters in the data, and we create a .NET string out of the name. All right. Before we do that, we will want to actually create this list of parameter names. And it's actually a list of these string guys. So let's see. Keep a list of parameter names around for easy sending of, or to make sending parameter values back to the editor a bit easier. Something like that. And I'm pretty sure you can actually create a .NET string out of a native string quite easily, if I can remember how it actually. So it's something like gc new system string or something. Str, yeah, exactly. So that's how you create a new string with a native string. So we do system. Actually, probably we can do m parameter names add, and then just gc new string, and this would be p data name and c string. Something like that. So now we have the parameter names. Now we can just iterate over those parameter names. We know that the index is already the same as we want, so we can use the index to get the parameter names. I'll get the parameter values and send them back. That makes sense, I think. Of course, here we know the seek speed. So for the parameters that don't have any seeking, in theory we wouldn't need to actually do anything. But let's not make that. Let's not actually have it behave any differently than seeking ones, unless it becomes like a performance problem. I'm thinking it probably won't be. Right. This looks good. Now we can probably create a new function here to actually package those together. So something that we'll call here. So we'll go to here and do a static void send parameter current values. Probably doesn't need to really do anything other than, or doesn't need any parameters, is what I'm saying. Like so. And we'll call it here update parameter values. Yes, exactly. Preview event instance, that is the instance, the one and only instance that we want to actually work with. That's cool. Right, now then, let's do for e equals 0 equal, or I needs to be smaller than parameter names count plus I. And that is actually unit 32. What? Oh, is that supposed to be like this? Yeah, it's just these weird properties that aren't really a thing in C++, but still are here then, using this weird C++ CLI dialect. Right, so we have the index, we have the name. So now we can just do float val equals and preview event instance get float parameter value with the index, which is I. And I'm assuming this index type def is probably just an alias for uint32, which it is. Yeah, the reason this this underscore is here is because this is a naming convention that I sometimes use to denote things that like the end user shouldn't necessarily call on the instance directly, even though in this case it technically doesn't really matter. Like this method is here and it is public, but it's really only meant to be used by other parts of the program, not the programmer itself. from something like the game code. So it's just like a small hint to the programmer that, hey, you shouldn't call this. It's called by other parts of the system. Right, and now the only thing we need to do is package this thing up into one of these messages and send it back. So message type, this would now be then update parameter current value. String data is this m parameter names. How do we actually get this out of it now? Can I do this? Can I do that? Does that actually give me... I don't know, let's see. I'm hoping it will. MSG float data, this would be val. Like so. Does that build? It does. Nice. Nice, nice, nice. So with all of this done, now we should be able to already see those values there on the editor side. So process return messages. And here you can see that we are actually using the exact same types here, even though now we are suddenly in C#. This is like the magic of the C++ CLI thing, that we can just continue working here in C# and it handles everything. It's all nice. So we can do string name. This would be message dot string data float val message dot float data, and we can do something like editor log write log, and then we do name is now val, the string, just to sort of see that these things are actually coming through. That is what we are interested in. Let's see if that works. Seek speed test. You can see that, okay, param is now 0. Speed is now 1000. Let's get rid of param. And this thing just keeps running, alright. Oh boy. Yeah, that's not good. I do wonder if the thread is actually running, or if we just flooded it with so many messages that it's like, it's not really. No, it is still running. Okay, that's not great. Event finished, message sent. Right. So we need to actually only send those if the thing is playing. If preview event instance is playing, we need to send those messages. We need to stop when it's no longer playing. Makes perfect sense, but I kind of figured this guy would die when it has stopped, but it evidently doesn't. So, nope. Okay, stop. And now it's stopped. That's good. We'll get rid of that other param there. We can clear that, and let's play it again. That's nice. Let's set it to something kind of high. We should see it going up there in the editor log. And now it's down to 100. Yeah. So we can clearly see that that the progress as it is seeking here, down from 2000 towards 100. So now we already have this information here. We just need to take it from this editor log and show it here in that thing instead. Okay. That's good. That's good. How do we make that happen then, though? I think, I might be wrong, but I think we are already on the main thread when we have reached that point. That's, I lost that somehow. Put a breakpoint there. I think we're already on the main thread when we have reached that place, which means that we can poke at the UI from there. Let's see if that is the case. Not actually hitting that. Might be because we are in release mode. Why are we not hitting that thing? There we go. Yes, so you can see here from the call stack that we are in the main thread. There's like a custom application idle pump here, which calls this process return messages. That's nice. That means that we can immediately send that stuff to the relevant place in the UI. That's very nice. Okay. And I was thinking we would sort of package that stuff up a little bit to make the updating faster. Not sure if we really technically need to do that. Let's close everything here so that we can have just the editor side here. So we have this parameter button. We looked briefly at this previously. So this is one of those buttons that we want to actually show the value in. And we now have the target value there. And we should uncomment this current value so that we have that as well, right? Target value. And we should probably have some sort of setter for the current value so that it knows how to actually refresh itself. But maybe we don't call it the current value. Maybe we call it like the displayed value or something like that. It kind of is the current value, kind of, but I wonder what the most sort of obvious name would be to actually, because we're not using it for anything other than just showing it to the user that, hey, this is now where we are seeking, essentially. And so yeah, here you can see that actually when we call set value on it here, this is where we're sending it to the preview player, which sends it as a message right above where we actually do the processing of the return values. Okay. Yeah, I don't exactly know what I want to call that thing, but for now maybe we'll create let's do it like this. I'm gonna uncomment that just like we did previously, and then we'll put it right here, float current value, and we could do both a setter and a getter for this one. To do invalidate. Actually, maybe we can just do invalidate here, like that. Return current value. Maybe that is as easy as it needs to be. Why is it set? Oh, that's get is what I want. There we go. Let's look at all the places where we have the target value, mouse click, parameter type, target value, init values. Yeah, initial value. Yeah, we don't actually want to set the current value at any point, I think. Instead, what we want to do is have the backend send it to us. Or do we actually want to update it here with the init values? Init values, initial value is that one. Yeah, I think that is perhaps like the only place where we actually want to set it. We'll see. See if that makes sense. Anyway, now if we have the current value, we can draw it. And the question is, how do we actually want to draw it? So here's the gauge, or however you're supposed to pronounce that. We're remapping a float, the target value from the min value to the max value. And then from 0 to the full gauge rect or gauge rect width. So yeah, that will fill in a rectangle. So maybe after that we can just do let's add another brush here. Current value brush. Let's look at what that brush is doing. It's gauge color. Gauge color is that. So I'm gonna do something that is just very obvious, very visible. So current value color yellow. And then we can do current value brush, a new solid brush, and current value color. And now using this, let's put that there. So full gauge rect, we can just actually get that out of that thing, because it will be the same for this one as well. But I'm thinking, rather than rendering the gauge, we would sort of we would make the width very thin, and then we would make the X this thing that we actually remap. So gauge, it can be called gauge rect, that's not a problem. X is that, and let's make it, let's put in here like an int and value indicator width, and we'll make that just like 4. And this can be called indicator rect. Indicator rect. Indicator width, so this would be -2 then probably. Or actually it would be exactly half that of the width. And the indicator rect width would be just that constant value. So it will sort of have like a horizontal, a vertical line across the thing where the current value is. And it's not target value, it is current value. So now we should already be able to see something, at least until we start messing with the. Yep, so we can see there those things, and we can see that it's a little outside of that actually. Interestingly, they don't line up. I did something bad. Let's see, current value. X is that, and width. Why do I actually not get it straight over the end of that gauge? That's interesting. Like if we put the target value here. What I'm expecting it to do now is start where that red section ends and then continue on from there, but it's evidently not doing it. So why is that? Oh right, it is because of this, right? So it's because of no, not what am I doing? It is because of this dot x plus that, right? That should be what we actually want. Yeah. Now it looks good, and now 0 is there, right there in the end. Yeah, well, the start, the end, it sort of goes over the end, but that is actually expected as well, because now I will uncomment this guy, and now we should have it beautifully sitting there in the end of the gauge. Yep, now it looks good. Now it looks good. So if like the seeking would be perfectly matched with the actual target value, if the current value would be perfectly matched with the target value, it would look like this. Whenever you're manually seeking this around, the seeking would follow it. But of course that is not what happens, and that is indeed not what we want to happen. We want it to smoothly follow along afterwards. But that is at least now being rendered correctly, if not beautifully. I will look at the visuals of it later, when I know exactly how I want that to actually, how I want it to look. But now the current value is not updated, not even if we play this. So it's just sitting there at the initial value. That is also expected. But what we can do now, at least hopefully, and at least in theory, is go into, what is it called? Is it called event editor form? And the event editor form has something called the flow panel. No, it actually has parameter buttons, has a getter for them immediately, so that's nice. So we can get the parameter buttons through here. They should already be in the correct order. Let's assume they are, but I'm pretty sure they are. So event editor form. Let's see. It's this thing. It is this thing. So, right, string data. Yeah, what we want is actually not the string. We want the index. Right? We want the index. I mean, that's fine. That makes it actually easier, but it just makes that means that we have to probably add like an integer data to this message. But for now, let's just not care about that. What I want to do here is do editor windows, Timbre editor windows, event editor window, parameter buttons. Param buttons. And we just have one of those buttons currently. So let's just use the 0th and set current, or is it just current value actually? Current value is val. As long as we have just one of those parameters, that should be enough. Let's get rid of that param one once and for all. I'm going to save this so it doesn't come back. Look at that. Yeah, so now we have the yellow line here is showing the actual value that we have going. And kind of annoyingly, it is left there in the button now when this thing is stopped. I'm thinking we probably actually want to hide it, because it doesn't really, well, it's not really applicable in this case. We don't have any current anything because we're not actually playing it, but that's a small thing change. And we can see that every time I play it, it starts from its initial value and tracks up to the current one. Yeah, cool. All right, I'm gonna change this communication between these two things slightly. So we don't actually need string data there at all. We just need int data. So the idea here is that we have a type, and then we have a few different members here, and whatever that data is, that depends on the type of the thing. So let's see what we have. If we go and replace this guy with a uint 32t, and we'll quite simply store parameter count. I think that's fine. And one thing that really trips me up every time is that we have like static C++ fields, members here, but you don't actually need to declare them like you do in standard C++. That's a weird thing here with this version of C++, this C++ CLI. I do have a reverb effect, yes, I do have a reverb effect. I will show it to you in a second, because this is basically like the last thing now that I need to do, and then I can show it to you. But I just want to get this fixed. That's a size. Size is what I want. So we basically just want to keep the number of parameters around like this, and put that there. We don't put any string data in. That can be null pointer, I guess, but I think it probably is implicitly that anyway. Int data would now then be not that, but actually I. Do we actually? Yeah, we do actually need it, yeah, or at least it's easiest to do it this way, like that. So int data, and then on the C Sharp side, we can quite simply do. Oh, but this is an no, this is an integer, right? Yeah. Like that. That's technically it's an unsigned int. This is an int. Yeah, I think I want it as an int. We won't have that many parameters or anything. Anyway, and I'd like to be able to represent negative values in this message. So I think that's probably a good idea. And besides, .NET actually uses ints for indexing in most cases. So it will be int parameter index message float data. It's called int data. Doesn't actually know about it. I probably need to rebuild my Timbre bridge project. And now I think it should basically work. So we can try it out. By putting in maybe like another parameter here. Let's call this volume. Volume can go from let's have it go from 0 to 2, and the ascending can be 0.1, 0.1, thank you, and descending 0.5. Like that. Put another one of these nodes here and connect that to the volume. And initial should be 1. And there you can see. Oh, it actually takes quite a long time for it to get louder. Hey, this is really nice. Now we can clearly see like those speeds there. You can see that. Okay, that's a little slow. Let's make it like 0.25. Right, the reverb. Yes, I actually have something called a reverb test here. So this uses one of my wave assets here. It's actually the same one that I used for the radio test. There's a video about this. I recorded some speech and then I created this monstrosity of a node graph here, which applies like a radio effect to it. Ground control to Major Tom. Commencing countdown, engines on. So it put some like some high pass filters and what is it called? It's called distortion and things like that on it. And I use the same wave clip. So the reverb filter comes in two forms: high quality and performance. The high quality reverb filter is essentially a modified version of the freeverb filter that comes with SoLoud. So if you go to SoLoud's website, if you don't know what SoLoud is, it is an easy to use free portable C++ audio engine for games. This is the thing in Basis that actually plays sound. Actually, that's not technically true, because SoLoud supports a number of backends. So I use Mini Audio as the backend. But SoLoud keeps track of things like virtual voice counts and 3D audio and mixing and things like that. And SoLoud comes with Freeverb. So Freeverb filter, which is a... what's it called, like a Schroeder something. Let's Google this. There's like a model for it. Blah 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 blah. Yeah, Schroeder Moorer. Make this a bit larger. Freeverb is a simple implementation of the standard Schroeder Moorer reverb model. So it basically uses 8 comb filters and then 4 all-pass filters. So 8 comb filters in parallel, and then 4 all-pass filters like right after each other. And that looks, that sounds really nice, but it can be a little heavy. I think this one actually even says, yeah, well, it sounds great. The filter is relatively heavy, should be used sparingly. So what I did was I added a performance mode to the So Loud Freeverb filter, which drops the count of those filters down by half. Oh, I actually have to take a phone call. 1 second. All right, sorry about that. Yes, anyway. Oh, hey, Summit. Nice to have you with us. Right, so what I did was I took the Freeverb filter that comes with So Loud and added a performance mode, which basically just drops the number of filters by half, which makes it sound a little rougher, but at least in theory makes it a lot faster. I haven't truthfully checked any performance yet. I haven't like profiled it, so I can't say how much faster it is in practice, or if the high quality is even sort of a concern. But that's what happens. And what this does is that it plays the first, or it plays the same wave asset twice, but first with the performance reverb and then with the high quality reverb. So we can have a listen. Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom, commencing countdown, engines on. So you can hear that there's definitely more reverb on the high quality one compared to the performance one. And if we crank up the wetness like a whole lot, this performance one starts to sound a little bit metallic. Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom, commencing countdown, engines on. You can even adjust this on the fly, just like with any other filter. But especially if you make the room size kind of large, bring the dampness down a bit, have the wet up to 1, the performance one starts sounding very, very metallic like. Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom, commencing countdown, engines on. As you can see, and it cuts off very abruptly, because like the audio clip, this node here and this node here, they just stop the playing when the reverb ends. So there's a little bit of, I'm not really sure that reverb should be applied to like individual assets like this. It's mostly like throwing them on one of the buses or something like that. So yeah, I don't actually have a single reverb filter yet in the game. I've been doing a lot of audio programming lately, and this is a somewhat recent addition. So we'll see, but I'm thinking I'll probably only use these at least in Traction Point with the buses, and not like this. This is just a very artificial test. But it can sound kind of nice if you don't crank it up all that much. If we bring it to like 0.30 maybe. Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom. Like I feel like there's a little bit of almost like volume loss with this performance one. Might want to make the dampness a bit higher. Ground control to Major Tom, commencing countdown, engines on. I want to be really careful with the room size because it can start to sound pretty bad. Ground control to Major Tom, commencing countdown, engines on. Ground control to Major Tom, commencing countdown, engines on. To be fair, even the high quality one sounds kind of like, it sounds like very much like you're in some sort of metallic warehouse or something. It doesn't really sound like a, you know, like a church or anything like made of stone. It's very kind of metallic. So it might just be basically how the reverb system works. But yeah, that's basically reverb for me. Also, if you want to use this, if you want to use So Loud, the So Loud filter, So Loud reverb filter currently expects there to be stereo channels, so two channels, which is not something that is, for example, the case with this wave asset. So I basically added support for mono channels as well. Stuff like that. I might have done something else as well. But that's a reverb for now. Yeah, so in this case, when we don't have any ascending or descending speeds, I don't think we should show this indicator here at all. And it probably shouldn't be yellow to be fair. Anyway. But I do like this a whole lot. We can now just mess around with this and see how it actually behaves. So, that is very nice. Most reverbs for music production have a way of filtering the verb. Yeah, I think with music production, like DAW level reverbs probably work in a completely different way. Like don't you typically, you give it some sort of like space profile, you give it sort of a wave file as input, and then it analyzes that and sort of applies that sort of reverb to whatever you run through the filter or something like that. Like isn't that basically what convolution is? So I don't think reverb has anything to do with that. It's just a simpler, at least sort of the, not necessarily performance-wise cheaper. To be fair, I don't really know, but I have a feeling like reverb is probably not like the most high quality one, but the implementation is kind of simple, and I think that is why it's used in these kinds of not that high-end products, if we're being completely honest here. But yes, that is my reverb story for now. And yeah, I think for something like Traction Point, where we're like mostly in outdoor spaces, you just want to add a very small amount of reverb to one of the like sound effect buses or something like that, so that everything just get a little bit of reverb, so that it sounds like it is like in an actual physical place. So far, if you've heard the engine sound that's being played back in the game, it sounds very sort of dry and well, doesn't really feel like it's sitting in the scene. And so I'm thinking and I'm hoping and I'm planning to just use reverb just enough to make it so that the sound sort of fits the scene a little better. Actually sounds like it's coming from something that is in the level. If you get my meaning. I'm not very experienced with game audio production or implementation or anything at all. So obviously I made my own system from scratch. That is how that's how you get that is how you get more familiar with things. Anyway, guys, I think this is it for today. I basically got everything done that I wanted. It works kind of nice. The UI needs some work still, but I will probably have to play around with that a little bit to figure out what I actually want there and how it should look like. Let's do a quick sneak peek at another thing that I've been working on lately. Oh, would you look at that? Timbre data format is wrong. We need to export this to the game, because yes, the game uses the same runtime library as we've been using all along. Oh, and it's still not doing it. Probably because we have the wrong project we have been opening. So we'll open the actual game project, export that, and shut it down. Thank you very much. Now it should run, hopefully. And it does. Yeah. So this sound that you can hear now, this is essentially no filters applied to it at all, and that's why it sounds very dry and boring and kind of unrealistic. But soon, hopefully, I'll get to actually adding more filters and doing like proper mixing and everything. But yes, what I wanted to show as a small sneak peek is the new mother vehicle, which now looks like this. Obviously, it's not done yet. It's not modeled. Not all of the pieces are modeled in their final shape. The crane, for example, is still lacking, and it's obviously not fully textured or anything. But the vehicle itself is starting to look pretty nice, and I think this is how it's going to be looking in the game. And I also kind of like the suspension because it is kind of following the shapes of the terrain kind of nicely. So now I need to add a bunch of sound effects and particle systems and everything to make this thing really come alive, because it is kind of nice to play around with and drive around with. I actually had to change the physics of the mother vehicle a little bit, because it just had some like completely ridiculous suspension line lengths and things like that. When you actually try to model something and you realize that this wheel can move like 3 meters up or down, it becomes tricky to get modeling something that could actually support those ranges. So I had to change it a little bit, but it's almost completely the same as it was before, which is nice, because that means that I don't have to change the level all that much. So that's kind of nice. But yes, that is what has been going on. Chassis shape reminds me of a hovercraft. Yeah. Yeah, it's a little weird, but that's kind of why I liked it. I tried out a few different shapes, and in the end I actually just started sculpting something, and this is kind of what I came out with. It looks vaguely sort of 50s. It's a little sort of the round shapes and everything. It's a little sort of not Half-Life, but Fallout 50s vibes inducing. But I kind of like that. I think that's a nice aesthetic. I might have to make it a little bit dirtier. I did do like a one paint over pass on this, painted some dirt on it, but might have to add some more and add some more decals and things like that to it. But yeah, I think it looks kind of nice. Now it's lacking like a really, really kick-ass engine sound, which is kind of why I started or switched to working on audio, which then rabbit-holed me into a bunch of audio-related tasks. But I think this is approaching kind of the final thing for this vehicle, which is, it's an important thing because this is like arguably the main character of the game, because these vehicles are sort of characters in themselves, and this mother vehicle is essentially literally a character because there's like an AI thingy associated with this. So not AI as in what you typically mean AI. I mean AI as in like Cortana or something like that. A nice kind of AI. I was thinking Captain Scarlet. I don't know what that is. Captain Scarlet and the Mysterios. Okay. Yeah, this has sort of like the same kind of 50s vibe to these vehicles and designs. This reminds me of Thunderbirds, which is not bad at all. Thunderbirds is awesome. So yeah, I'm glad it evokes those kinds of feelings. Mission accomplished, I guess. Anyway, people, thanks for hanging around today. I think I'm pretty much done. I might do a little bit more audio programming this weekend. I might even do it on stream. It kind of depends on how things are progressing and all of that. But stay tuned if you like this kind of stuff. I'm sure there'll be more of it sooner or later, hopefully sooner. Anyway, have a nice weekend, everyone. Hope to see you around. Hope to see you in the next video. Like, subscribe, do all of the things.